Okay, so basically, suppose there's an event which is A, which could be executed in n different ways, and there's another event which is B, which also could be executed in m different ways. So, what is the possibility that M or A or B is being executed, either of them being executed? So, if A could be executed in n one different ways and B could be executed in n two different ways, we can easily say that if A is being executed as n one ways and B is being executed in n two different ways, then we can execute either of them in n1 plus n2 different kind of ways. Very obvious. But what do we mean by multiplicative rule of counting? That was additive rule, right? Basically, or A or B, A or B being executed. Now, what if I'm trying to make assumption regarding the ways in which A and B both are being executed? How many different ways are there? How many different ways there are supposed to be? Like, A could be executed in n1 different ways, but B could be executed in n2 different ways. Now, what is the number of possible ways in which we are able to execute A and B together? So, in this kind of scenario, I can imagine it as a function or maybe a set where A is a set of n1 entities, and entities are or elements are the possible ways in which the event could be occurred, like this one. Suppose A could be executed in n1 ways, okay, and B could be executed in n2 ways. So, what is the possibility that, what is the number of possibilities that A and B both could be executed? In that scenario, what we'll be trying to do, we'll trying to create another set of all possible combinations, which will be nothing but a ordered pair. Okay, ordered pair. Yes. So basically, if this is a ordered pair, then uh, we can easily assume that each element of the set is a way to execute A and B simultaneously, right? If that is true, then the number of available elements in this set or cross product is the number of ways in which we can execute A and B simultaneously. Isn't it? If that is true, then if we can find the number of elements in the set of this ordered pair, which is nothing but the cardinality of the cross product. So if you are aware with the set theory, then you'll easily assume or easily get it, like what is cardinality and what is the ordered pair. So if we are able to find the cardinality of the ordered pair, that will give me nothing but the number of possible ways in which A and B both simultaneously can occur, right? Till now, any doubt? Any question, guys? Okay, so let us. Okay, is there any question you can
No,
ask?
sir.
Okay, so in this scenario, we can come up with some examples as well. So let us see one. Creating a alphanumeric code. Okay, suppose you were asked to create a 6-digit alphanumeric password with the following statement. Password should have first two letters followed by four numbers. Okay, so basically there are six available spaces where I can put six available spaces where I can put uh, alphabet or numeric uh, or numbers. Okay, now first two should be letters. Here I can paste only letters. Okay, and these spaces are allotted for numbers. Okay, so how many possible ways are there? First tell me which principle we should be using here, addition or multiplication? Anyone? Just take a wild guess. If you are not aware, then you can take a wild guess. It would be beneficial for you guys as well if you like interact. Okay, so in this scenario we are following the multiplication property of counting. Why so? Because here these numbers or letters, the combination is consisting letters and numbers simultaneously. Okay, not individually. Okay, I haven't asked that what is the way that you can put it over here, put a letter over here, or you can put a letter over here. I have asked you what is the possibility that you can put a letter over here and you can put a letter over here simultaneously, right? So there's a basic difference of and or. Okay, so if you are going forward with such a sense where you are getting an option that A or B, then you should be always following addition rule of counting. But if you are getting a sense of A and B together, then you should be following the multiplicative rule of counting. Fair enough? Any doubt? Okay. So now there could be those two scenarios. Okay. Where you were allowing repetitions. What do you mean by repetitions? That if a particular letter is occurring at the first place, you allow the system of generating the password, you allowing it to repeat it again for the second place, second letter space. Okay, there might not be the same thing, but you will not be discarding it if the letter is being repeated, and same goes for the numbers. A particular number can repeat 4 times. Okay, that you are allowing, right? Cool enough? Now, if you are not allowing it, then if a particular letter is being placed at the first place, you cannot place it again on the second letter space. Okay? So, which is reducing the number of available choice I have by 1. Okay? So, let's calculate. Okay? In this scenario, if the first place is containing one letter, I have 26 letters, and if I am allowing the repetition, then the second place also having choice of 26 different letters. Similarly, for the numbers, we have 10 choices for each places. Now, if I am not allowing the repetition, suppose a particular letter is being used. Suppose I have pasted A over here. I cannot use A in this place. A is being forbidden to be used. So I am available with 25 choices of the letters, right? The options or the choices are getting reduced by 1 just because I have used something here. Okay, so I am multiplying it with 25. Same goes with numbers. I'm starting with 10, and the number of choice is getting reduced by 1 each time I'm placing something on the place. So eventually I'll be remaining with 7 choices at the fourth place. Cool? Any doubt so far? Okay. Now, from this reducing choices, a concept arrives called factorial. Okay. What is factorial? The product of first n positive integers. Okay. What is integer? Counting numbers. Okay. It's called n factorial, and it is denoted by n factorial sign. Okay. So if I am writing this n factorial, I mean I'm multiplying 1, 2, 3, and it's going up to n. Okay, cool. This is the expression. I am assuming you all are aware of it. Now, in general, suppose I'm writing n factorial. Okay, uh, let me write it. Writing n factorial. What does this mean? N factorial n into n minus 1 into n minus 2, and it will go up to 1, right? Now, can I say this n minus 1 factorial? Cause this part is nothing but n factorial only, right? N minus 1 factorial only, isn't it? Okay. Fair enough.
Yes, sir.
Now, can you give me the value of 0 factorial?
It will be 1.
Yeah, how? Of course, it will be 1. We all are aware of. But how? Can you answer that too?
No idea, sir.
Okay.
Sir, is it because of the multiplicative identity?
Yes. Can you explain a little bit? Like, I would like to hear from you guys.
So basically, 0 can be only represented as an empty set, right? Or an
No.
empty number. So it might be represented only as 1.
Like,
I'm not sure, sir. Just guessing.
okay, I get it. Can you tell me what is the value of 1 factorial? Anyone? What is the value of 1 factorial?
It's 1, sir.
1. Can I write it in this format as well? Like 1 factorial is nothing but 1 minus 1 factorial. Because I'm assuming that n is nothing but 1, right? If n equals to 1, then n factorial is equal to n into n minus 1 factorial. Then 1 factorial is nothing but 1 into 1 minus 1 factorial. Can I say this? Yes or no? Okay, let me write it with uh, a clear canvas. Okay, n factorial is nothing but n into n minus 1 factorial. We just saw that, right? Any doubt regarding this one?
No.
Okay. Now I can write 1 factorial is equal to 1, right? I can also write 1 factorial is nothing but 1 into 1 minus 1 factorial according to this. Okay. Now 1 factorial is nothing but 1 into 0 factorial, right? Now what is the value of 1 factorial from this? This is 1 only. 1 equal to 1 into 0 factorial. What is the value of 0 factorial? 1. This will go this side. 1 by 1, which is 1 only. Okay. From this, I can infer that 0 factorial is equal to 1. Okay. Cool.
Yes.
Okay. Do you have any doubt regarding this till now? You can ask. If you think like, yeah, it's not mathing properly, then you can ask. Like, would you like to contradict? Okay, let us proceed. Let us solve a question now. Yep. So, in a building, 6 men and 4 women are staying. Okay. You know there are exactly 3 marital couples. How many ways you can guess who the couples are? Okay. Suppose I have a set M. Okay. Which has 6%. So what is the cardinality of M? Is 6. Fair enough. Okay. Now I have another set of women. Um, Here also I have 4 women. So what is the cardinality? Oh, okay. Number of married couples. So suppose this is a ordered pair, this is another ordered pair, and this is another ordered pair. Okay. So for the first couple, how many choices I have for the man? I have 6 choices, right? Yes or no? I have 6 choices. So, yeah. Now, one man cannot be married to multiple women, right? So, I have 5 choices in this section, and I have 4 choices in this section, right? Yes or no? Yes or no? Can you like
Yes, sir.
Yes, sir.
now? I have 3 available slots for placing women's, right? So I have to choose 3 women from 4. Like from a set of 4 women, I have to choose 3. So I'll simply use 4C3, right? Yes or no? Which is 4, right? Now tell me, am I have 6 choices, right? For the first man. I have 5 choices for the second man. I have 4 choices for the third man. These things are happening simultaneously or separately. Like I'm telling, I have 6 choices for the first man, or 5 choices for the second man, or 4 choices for the third man, or I'm telling I have 6 choices for the first man, and I have 5 choices for the second man, and I have 4 choices for the third man. Which phrase is more appropriate, or and? Aren't this happening simultaneously? What do you think? Aren't this happening simultaneously?
Sir, it should be and.
It should be and. So if it is and, then what principle of countings we should be following? Multiplication or addition?
Multiplication.
Exactly. So we will be multiplying all the choices of the men, and simultaneously we have 4 choices in which we can allocate women in each couple. Okay. So basically, what we are trying to get, 6 into 5 into 4 into 4. You can ask why we are doing now, allocating the men first. You can do the vice versa as well. So in that scenario, what you will be having? You have 4 choices initially, then 3, then 2, right? 4 into 3 into 2, and then again you will be choosing 3 men from 6, right? This will consume more computational power for you to find the combination. That's why I went for the easier process. Cool. I guess. Okay. Let's solve another problem then. Okay. A fair die is rolled and a fair coin is tossed. Okay. how many different ways a pair of outcome a die and coin can generate. Yeah, cool enough. Here, a die can generate 6 different outcomes, right? And a coin can generate 2 different outcomes. Okay. Now, tell me, are these happening simultaneously or not? Coin a coin is generating 2 different outcomes. A dice is generating 6 different outcomes. Are they happening simultaneously, or they're happening separate in a separate way? They're happening in simultaneous way, right? That's why they have also mentioned and in the question. So what we will be doing, we'll be simply multiplying the number of distinct outcomes, and we'll be getting 12. Okay, if you think it from a ordered pair perspective, okay, then also you will be able to visualize it. Suppose, yeah, die is generating this sample set. This sample space is being generated by the die, and the coin is generating this one. What would be our cross product? 2 comma head, and you can go on, right, like this. And again we'll start with 1 comma tail and 2 comma tail, like this. So we'll be having 6 different elements consisting head as its second component, and we'll be having 6 different uh, outcomes consisting tail as its second component. So what will be the cardinality of this ordered pair, the cross product? This will be 12 only. From this point of view, you can also visualize this problem. Okay. Now, okay, we have few problems over here. Mm, you can try this lately. Now we are switching to week 6. Now here we go again with permutation and combination. What exactly permutation is doing? Okay. Permutation, the term we used earlier, though, the permutation is an ordered arrangement. Okay, so this is an arrangement, okay, where order matters. Okay, so basically, suppose 1, 2, 3 is there, and 3, 2, 1 is there, then we should be considering these two as different elements in permutation. Okay. Okay. Suppose I have created a group of 2 boys and a girl. Okay. But if I change the ordering, if I change the ordering, I should be considering it as an different group. Okay. So if I am considering it as a different group, then only I can say that I have taken a permutation, not a combination. So what is the difference between permutation and combination? We will be discussing laterly. So this is basically the general idea to distinguish. Okay. Now there are two type of permutations you can usually come up with. One is repetition is allowed. This is called WR. Sorry, WOR without repetition, and second one is repetition allowed, and the first one was repetition not allowed. WR. One is WOR and WR. Okay. How I can uh, find the number of ways I can create I can permutate. So there's a formula which includes the concept of factorial in it. So if I am permutating R elements, okay, I'm choosing R elements from N elements. Okay, with ordering. Then what is the number of ways I can get it? This is the formula. Okay, n factorial by n minus r factorial, and this is denoted by NPR. Okay, any doubt?
No, sir.
Okay, now what if I'm choosing zero zero elements? Suppose I have a box of pens. Okay, now I'm choosing zero, so there must be only one way to choose nothing, right? So
Yes, sir.
mathematically also you can show that. Okay, if r equals to 0, n minus 0 is nothing but n factorial, which will lead me to one trivial way. So basically you can call it trivial choice. Okay, again, if you are choosing only one, you have 5 pens, you have to choose only one, right? If this is the scenario, you can choose any of them, and you can choose 5 of them individually, so you have nothing but n number of ways. This is also a trivial choice. Trivial case, not a trivial choice, but trivial case will have n number of ways, right?
Yes,
Now if you are choosing everything, but this time ordering matters. Okay, suppose you have 5 pens and you are choosing 5 of them. Okay, so in this scenario, how many ways you can choose them? Why not one? Why n factorial it is saying? Because you can um, exchange the ordering of choosing a particular pen, and that will give you a different way of choosing in permutation while ordering matters. So that's why you have n factorial ways. Okay, so let us see some applications as well. Um, from a committee of 8 persons, in how many ways we can choose a chairperson and a vice chairperson, assuming one person cannot hold more than one position. What does that mean? One person, by ensuring that one person cannot hold more than one position, I am telling that repetition is not allowed, right? And here ordering matters, right? Because suppose there's a person A and person B is being chosen. Now person A is being allotted as chairperson and person B is being allotted as vice chairperson. Now the same thing has been done, A and B has been chosen, but A has been allotted the vice chairperson post and B has been allotted chairperson post. These two are considered as different choice, not identical. That's why here ordering matters. So we should be going with permutation. Okay. Now once we are going with permutation, we have to choose two people from eight of them. So basically we are trying to get 8p2, which will lead me to 56 ways. Okay, clear? What if what if permutation was allowed? What is sorry, repetition was allowed in permutation? Suppose, let us take the same thing as well. I have three-person. Among them, I have to choose a chairperson and a vice chairperson. How many combinations could be made? A could be done, which wasn't allowed. These notes, yeah, I'll be sharing it. After the session, I'll be sharing it in the group. And I can take B. Okay. Uh, I can take C. Similarly, I can take ABC, and ABB. I can keep doing this, right? So, what I am choosing basically, I am choosing three-person out of three persons, right? So this will lead me to now this number, 3 to the power 3. Okay. So the general formula is n to the power r. So n p r will be n to the power r if repetition allowed. Okay. Fair enough? Any doubt? So that we can elaborate a little, or we can jump towards combination. Okay, let us move on. Okay. There's a way of doing circular permutation. In this scenario, we just do nothing. Um, Basically, if we are asked to take n number of choose n number of distinct object, We just take n minus 1 factorial. That will lead me to the thing. Okay. We have a combination thing, yeah. So, okay. So, what is different in combination from permutation? Can anyone put some light on combination? In combination, it's similar to permutation, just in this scenario, the ordering doesn't matter. So, earlier, if I was choosing ABC and I was choosing CBA, it was considered as two different cases. But in this scenario, these two cases are similar. Okay. Suppose there are three people, A, B, and C. I am choosing any two of them without repetition. So I could choose this and this. In permutation, these two are considered as different cases or different choices. But here, these two are similar because the ordering doesn't matter. Okay, cool. Understood? Any doubt? We'll be going to a little deeper, of course. Yeah. So, if I was asked to choose R elements from n, the formula should be n factorial by n minus r factorial, which is similar to the permutation formula. But r factorial term will be dividing the permutation formula. Why? Because it is reducing the number of choices by the number of identical stuffs. Okay, so it is reducing the significance of the ordering by r factorial. Okay, so I can say that this is nothing but npr into 1 by r factorial. Okay, oftenly you will be seeing people writing this. Okay, this is nothing but ncr. Okay, cool enough? Any doubt? Any doubt, guys? Okay, so some useful results you should be knowing. Yeah. Yeah. Suppose we have been asked to choose r elements from n. I can write it as n factorial by r factorial by n minus r factorial. Okay. What is the condition here to satisfy? We need to satisfy that this r should be cancelling this minus r, and the total should be equal to n. So we can easily swipe it. N factorial, n minus r factorial, and this one is, I can write r factorial here also. Okay, cool. This will lead me to nothing but n c n minus r. Okay, so basically NCR is nothing but NC n minus r. Okay, cool. Now, what will be NCN? NC, sorry, NCN is nothing but n factorial by n factorial into 0 factorial, which is n factorial by n factorial, which is 1. Okay, and from this formula we can also say that nc0 will result the same. Okay, any doubt? Okay, let us do few questions then. Yes, choosing a cricket team. Select a cricket team of 11 from 17 players in which 5 players can bowl. The requirements in the cricket team of 11 must include exactly 4 bowlers. Okay. Total number of players, available players, 17. Number of bowlers, 4. We need 4 bowlers. Okay. So we need to choose 4 bowlers from 5. Right? How many players are remaining then? How many players are remaining? We have 12 players remaining, and from then them I have to choose how many? Can anyone tell me? 7, right? So if I multiply, this is nothing but this 5c4 into 11c7. You just calculate it. You have your calculator with you. In exam you will be getting a online calculator, TCS ion calculator, that will also help you to calculate. Okay, clear? Now we'll be jumping towards next week content, as we have a time constraint. Won't be going in that detail, but for sure you'll be getting it in your like notes and slides as well. Okay, now let us talk about probability. What do you mean by probability? Can anyone tell me what do you mean? But what is the concept? What is the thinking that appears whenever you listen the word probability? What is it?
So chances of an event occurring.
Exactly. So what are the chances that a particular event or a certain event is being gonna be occurred? So basically, determinants of the likelihood or the chance that event will occur. Okay? But to construct the mathematical or statistical definition of probability, so there are few type of definitions, axiometric definitions and mathematical, classical. You will get to know. Um, Eventually, you will get to know about three of them. Uh, like, let me jot down. First, you will be familiar with classical, and then you will get introduced to axiometric. Then maybe you will face statistical definition, and at the last you will get a mathematical definition. Okay, these are not that much important for you right now, but to construct the definition of um, probability, you should be knowing some notions like random experiment. uh, Whenever you are listening the term random experiment, a question should be appearing that uh, so far we were aware of the term experiment, right? In other subjects like physics, we have seen experiments. uh, Now how this random experiment is different from the experiment? So can anyone tell me that what do you mean by experiment? Anyone? Experiment is something like you are performing a process and you will get an outcome, right? Like example, titration. You are performing a process, you will get an outcome. But what is random experiment? Random experiment is a such kind of experiment where you are performing a process, but you cannot predict the outcome with certainty. But all the possible outcomes are known to you. Example, you are tossing a coin. You are tossing a coin. You know that either head will appear or tail will appear. All possible outcomes are very much known to you, right? Okay, it is very much known to you, but you cannot predict with certainty that yeah, head will be appearing for sure. You cannot. This is why these kind of experiments are called random experiments. Another example, rolling a die. You are rolling a die, you know it will result you a number between 1 to 6, or to be very precise, it will give you an integer between 1 and 6, endpoints included. But you cannot predict which number will be appearing. Okay, see, here also it is mentioned. However, although the outcome of the experiment will not be known in advance, let us suppose that the set of all possible outcome is known. Okay. Now, the all possible outcome which I just told you, if I construct a set, okay, set of all possible outcome of a particular random experiment is called the sample space of that random experiment. Cool. Now there are few properties it should be like obeying. Firstly, mutually exclusive. Okay. One particular, uh, if the random experiment is being conducted, one of the particular outcome could be occurred which can included in the sample space. There must not be a scenario where two of the elements are being appeared simultaneously. Okay, and it must be exhaustive, like there shouldn't be any outcome which is occurring due to the random experiment and is not contained inside the sample space. Okay, so it would be beneficial if you can construct a example on your own, but let me give you as one as well. Suppose I'm tossing two coins simultaneously. Okay, two coins I'm tossing simultaneously. What could appear? Head, head. Both could result head. Head, tail could appear. Now, tail, head could also appear, and tail could also appear. There's no possible outcome which is outside the scope of this set. Also, there's no two sets, no two outcomes which can occur, no two elements which can occur simultaneously. Fair enough? You can construct one on your own as well. Now, event. What is an event? Uh, if I try to give you the simplest example, then occurrence of any subset of the sample space. Okay, is called event. Okay, it's called an event. Example of an event. Okay, guessing out answers to 4 options MCQ. Okay, and the answer is A. This could be a event like A is the right answer. Okay, suppose A is the right answer. Tossing two coins. Event, getting first toss as head. So this is the scenario. Head, 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 tail. In this scenario, both the scenarios, first toss is resulting me head. Now we can thought of union of events. Why we are naming it or mentioning it as a union of events? Because if you visualize it, you will get to see that event is nothing but a set. And earlier I also mentioned that an event is a subset of the sample space. So we should be able to perform all the set operations on a event. Okay. Suppose I am saying occurrence of event A or event B. This is nothing but union of events. I am collabing two or more events simultaneously. Similarly, we can thought of intersection of events. Okay, like if I say uh, let us visualize a event where both event A and event B is occurring simultaneously. In this scenario, suppose this is the probability of event A being occurred and this is the probability of event B being occurred. This is the probability that both are being occurred. So nothing but I'm taking nothing but the intersection of two events. Okay. Null event that doesn't occur at all. Probability of such a event is always zero. Okay. What do you mean by disjoint event? Suppose A is being occurred, B is being occurred. And if I take the intersection, it will be zero always. Like there's no possibility that A and B can like win or occur simultaneously. Let's take an example. Suppose a final match being played between India and New Zealand. There's no possibility that India and New Zealand are winning simultaneously. So these type of events are called disjoint events. Okay. Complement of a event. Suppose I have an event occurring uh, okay. Suppose I have wrote exam. I have written exam. Okay. Now I'm trying to find the probability of me passing the exam. Me passing the exam is event A, event E. Now, if I try to take the complement, which could be denoted by this, okay, these are different notations. You can use any one of them, okay. This will be the the event where I am failing the exam, okay. Failing the exam. Cool. Like a single coin has been tossed. Event one, event one is nothing but getting a head, and event two is getting a tail. They are complementary to each other. Okay. Any doubt so far? Any doubt? You can
No, sir.
ask. Now we'll be talking about the definition of probability, which is the basic definition is classical probability. Suppose S be the sample space. Okay. Okay. S be the sample space of a random experiment. And I have taken a event E. Now here I have to take few assumptions. Okay. Assumptions are, first assumption is the events are equally likely. What do you mean by equally likely? All of the elements within a subset are equal probable that they will occur. Okay. Matlab, that means each elements of the sample space has same probability of occurrence. Also, the sample space must be finite. So there should be countable number of possible elements which could occur. There must not exist uncountable number of elements in sample space. Okay. If these two conditions are being satisfied, then only we can construct a definition of probability in classical way or theoretical way. In this scenario, what is the probability of occurrence of E? Is nothing but cardinality of E by cardinality of sample space, where S be the sample space. And E must contain exactly M elements and S must contain N elements. So this will be M by N. Okay. Cool. Any doubt so far? Now we should be knowing that classical probability doesn't work everywhere. Okay. Suppose I have a coin which has both sides, edge and head and tail. Now, in general, head and tail are equally likely to appear. But what if we have a biased coin which has 1/3 probability of appearing head, 2/3 probability of appearing tail? Now we cannot find the probability with classical scenario. In this particular case, we need to go forward with the a little advanced methodology, which is called axiometric definition of probability. In this scenario, we will assume or we will follow 3 axioms to construct the definition of probability. Okay. What are the axioms? Firstly, suppose I have an event E. So the probability of E is a number between 0 and 1. or a probability should be proper fraction. Okay. So what is the range of probability? It belongs to 0 and 1. Okay. This is the first axiom. You can think of probability as a function which has a range of 0 to 1 with closed interval. Okay. Now, probability of the sample space must be 1. Okay. Probability of sample space must be 1. What does that mean? Probability of an element being occurred contained within the sample space is very trivially 1. So, a element being occurred that must contained within the sample space. Okay. And third one, for a sequence of mutually exclusive or disjoint events, the probability should be summing to each other, given there's no intersection effect. Okay. Like you have tossed a coin, probability of getting a head and probability, sorry, or probability of getting a tail is nothing but this. So probability of getting head or tail is nothing but probability of getting head plus probability of getting tail, given that occurrence of head and tail are mutually exclusive, right? They are mutually exclusive. They can't occur simultaneously. Okay. Clear so far? Yes or no? Any doubt? Anyone? You can ask right now. If no, then we will be concentrating towards something. Few more questions. Okay. So let us solve few questions from previous year. What it has asked: from a box containing 5 chocolates and 5 dark chocolates, 3 milk chocolates, 3 chocolates are to be selected randomly without replacement. Okay. So what they have asked: I have 5 dark chocolates. Okay. And I have 3 milk chocolates. Okay. 3 chocolates are to be selected randomly without replacement. Okay. Now at least 1 milk chocolate should be selected. Okay. So from 3 of them, at least 1 I am choosing. Okay. And from 5 I am choosing 2. Okay. This could be a scenario, case 1. Case 2, from 3 I'm choosing 2. Okay, and from 5 I'm choosing 1. And case 3, all the chocolates I have chosen is from this milk chocolate box. They boxed at least one, right? I could go with higher number, right? Yeah. Now, what is the answer then? 3C1. What will be the answer? Tell me, anyone. What is the value of 3C1? Tell me. 3C1 is 3. What is 5C2? Nothing but 10. So in this scenario, I have 30 possible ways. What about this? 3C2 is also 3, right? 5C1, 5. So this is 15. Okay. And what if 3C3 I have asked? This is nothing but 1. And 5C0 is also 1. So this 56. Okay. 56 is the answer. Any doubt?
No, sir.
Okay. Next question. Okay. Suppose Ankit has 2 empty pen boxes, which are to be filled by 3 pens. In how many ways can the boxes be filled with pens such as none of the boxes are remaining empty? 2 boxes and 3 pens. Tell me. How many ways are there? Anyone? What is the principle working behind it? Is this working with ordering manner or with replacement, without replacement? Any idea?
Sir, is this without replacement?
Yeah, you take a guess. That is why what I asked right now, right? Okay, suppose you placed a pen over here only. Okay, can you place it again in this box?
No, sir.
So is it feasible in real world to place a pen with replacement? With replacement means there's a replication, right? Is it possible in this real world to replicate a pen?
No, sir.
So this is obviously without replacement. So now in without replacement scenario, how can you manifest it? For this particular pen, how many choices are there? It can go to this box or it can go to this box, right? There are two choices. For this pen as well, there are two choices. Similarly, for this pen, you got two choices. So how many total choices you got?
8, sir.
2 to the power 3, which is 8. Now, I have been given a constraint, which is none of the boxes remain empty. Okay. What is the scenario where the boxes are remaining empty? Suppose all of them have chosen this box, right? So that is a way which is not allowed. I got a way which is not allowed. Another way I got where all of the pens are choosing to stay on in this box. Okay. So there are two ways which are not allowed. So what I'll be doing, I'll just subtract that. So my answer is 2 cube minus 2, which is 6. Okay. I'm acknowledging that I have 2 to the power 3 ways to arrange. To make sure that no boxes are remaining empty, I have to eliminate these two extreme scenarios where all three pens are choosing a single particular box. Okay. So I'm eliminating 2. Clear? Yes or no?
Yes, sir.
Okay. We'll be solving few more questions. And okay. Let us consider two events. Throwing a 4 with one unbiased die. So what is the probability of getting a 4? 1 by 6. Throwing a sum of 8 with two independent rolls. Okay. Now, two independent rolls they have told us, right? 8 I need. So 2 plus 6 could occur. This could occur as well. Again, 4, 4, 5, 3, 6, 2. Right? These are the scenarios. 5 scenarios. Out of how many? 6 to the power 2, because 2 times I am rolling it, right? So nothing but 5 by 36. So probability of A is 1 by 6. Probability of B is 5 by 36. Which one is higher?
A, sir.
A is higher. So which event has maximum probability? A.
A. Sir, I believe there is one question before this one, I guess.
Yeah, I'm skipping few questions so that I can like touch each genre of a paper.
Okay. Okay,
If
sir.
I keep doing it simultaneously, I will concentrate towards one particular topic. So
Okay, sir.
for the time constraint only, I'm skipping few questions. Yes. Okay. Let us do this. X contains observation of the speed of a car. Okay. Y contains observation of the speed of another car. It is noted each observation of y is half time each observation of x. Okay. If sample variance of x is 64, calculate the sample covariance between x and y. Okay. This was the part which I didn't cover in the theory, but can any one of you like would like to solve? Anyone? In week 8 only, I guess you got introduced to variance covariance problems. By the way, tell me how many of you haven't watched week 8 content yet? Content yet? Week 7? Okay, basically here x and y are two random variables, okay? Y is nothing but half of x. Cool? Now they have asked us to find out this, which is nothing but covariance of x and half x, right? Now there's a formula. Okay, let me write it here only. There's a formula. If covariance of x and alpha x I'm trying to find, it will be alpha into variance of x. So this will be half into covariance of x, sorry, variance of x. Okay. Now in the question, they have already mentioned the variance. So half into 64. Okay. There are different approaches as well, but this one is more suitable. Cool enough? Any doubt?
No, sir.
So you guys are aware of variance and covariance, right?
Yes, sir.
Okay. Could you tell me what is variance?
Like the general meaning, sir?
Like what it is signifying? Why variance is needed in our life? Just tell me what is variance. That will also be enough.
It basically helps in calculating the differences, sir, or
Okay,
the
differences between
variabilities in the data.
variability of the data. Exactly. Variability inherited by the data. Okay.
Yes, sir.
Variability from what? Basically, this is a measure of dispersion. Okay.
Okay.
So this is signifying that how far your data points are spreaded from the central point of the data, which is mean. Okay.
Okay,
So
sir.
how far it is spreaded from the centrality. Okay. Fair enough. Next, we have few observations. What is the sample variance? Okay. So first, what we need to do? We need to find the mean. What are the observations? 30, 35, 25, 40, 45. Okay. Cool enough. So if we sum them all, and divide it by the number of observations, it will be nothing but 20 plus 85 by 5. I guess I'm doing it correct. 175 by 5. What will be the answer? 35, right? Isn't it? Which is giving me the central value. Now, what I need to do is find the variance. What is the like formula of sample variance? Can you tell me? Anyone? The formula of sample variance is xi minus x bar summation square, sorry, sum of xi minus x bar square by n minus 1, right? Cool enough. So this will be minus 10 square plus minus 5 square plus 0 plus 5 square plus 10 square by 5. Okay, 100, 100, 25, 25. So how much it will be? Sorry, this is 4, not 5. N minus 1. Yep. So this is nothing but 250 by 4. 62.5. Okay, cool. Any doubt? Any doubt regarding the formula or the computational method?
No, sir.
Okay. So if I give you few observations, can you find it? Uh, let's try. Mm, suppose 15, 20, 25, 30, and 35. Let's find out what is the sample variance. Okay, not population variance, sample variance we are concentrating right now. So what will be the sample variance of the observations? Suppose these are my xi's. Okay, find out and let me know. I'm giving you 2 minutes to solve. I hope this will be beneficial for you guys if you practice a little bit. Is it done?
No, sir. 1 minute.
Okay.
Sir, is it 68.75?
Around that only. What is the mean, by the way?
The mean was 25, sir.
25. Yep. Fair enough. Okay. Let us do this. The sum of length and breadth of a rectangle is 12. So x and y. So we know x and y is 12. X plus 1. Find the probability that the area of the rectangle is not less than 3/4 time of the greatest area possible. Okay. So greatest area possible, right? When it will be happening? If x is equals to y, then x square maximizes, right? Yeah. This is the scenario where x square or xy maximizes if x equals to y. Now they have asked that x y is not less than 3/4 of x square. What is the probability? What is the probability, and how you can approach this question? Can anyone tell me any approximation? If suppose there's a scenario when xy maximized, okay, area has maximized. That means x is equal to y. Also, x plus y equals to 12. The constraint is given. So x equals to nothing but 6. Fair enough? Yes or no?
Yes, sir.
Okay. Now, what is the possible range of x? X must be greater than 0 and less than 12. We can include, we could include the equality, but not including strictly, because x can never attain the value 0 or attain the value 12, because y couldn't be 0 neither 12, right? Otherwise it will diminish another dimension, so that is no longer a rectangle, right? Now by this constraint, what I am telling it, I'm just telling that okay, this is it. Yes or no?
Yes, sir.
Now this was the range. X could have attained any value between 0 to 12. Now, due to this constraint, x can attain any value between 0 to 6. Okay?
Sir, so will the greatest area possible be 36? we're considering x as 6.
Yes, but I'm not going into that argument. We can compare between areas, but I'm telling if x is attaining 6 or the area is attaining the maximum value, then what is the value of x? 6 only. Now I have a constraint that earlier x could have attained any value between 0 to 12. Now, because of the constraint that it couldn't be three-fourth times of the greatest possible value, not less than that, it cannot attain value beyond this range 0 to 6, right? Yes or no?
Sir, it's slightly confusing, sir.
Okay.
So the question is asking that it should not be less than 3 by 4 times of the greatest area possible, right? So shouldn't we take the greatest area into consideration so that it would be easier?
Okay, then let me do it explicitly. Yeah, uh, Tanisha. Yeah, go ahead.
Yes, sir. Good evening, sir. I had the same doubt. Like, why are we taking six as a higher limit? Can't we take it as a lower limit?
Yeah, we can actually. That will also slice it in half. Okay, let me do it explicitly. That would be beneficial.
Thank you, sir.
Mhm. Wait a minute. Uh, Hold a minute. Let me open the whiteboard. Excuse me for a minute. Yep. I guess my board is visible, right? Is it visible to you guys?
Yes, sir.
Okay. Now, suppose area. Okay. Area is nothing but x into y, right? And area will maximize max uh, when x is equals to y, right? Yes or no? Now, if area maximizes, then x must be equal to 6 and y also must be equal to 6, as x plus y equals to 12. Fair enough? Any doubt?
No, sir.
No, sir.
What is clear, right? Now, we need to we need the probability that area is at least three-fourth of the maximum area. Okay. So, what is the three-fourth of the maximum area?
27, sir.
Yes, 27. 36 into three-fourth. Okay. If this is my maximum area, then what is the possible value of x and y? Okay, let me check that. x into
Sir,
y.
9 and 3.
Yeah, that could be, yeah, that could be a possible value. uh, any different another choice? 9 and 3. So we have two constraints, right? That x and 3 y must be greater than 27 and x plus y is 12. So any another choice we have? Do you have any another choice? Actually we don't. But if you solve the inequality, if you solve this inequality and with help of the auxiliary equation, you will get the value, right? So this is the scenario. It can't go beyond this, right? This is clear now, right? That it can't go beyond this. So what is the range of x? It was earlier. What was the range? 0 to 12, right?
Yes, sir.
Okay. Now, what is the range of x now? It can go, it cannot go um, beyond 9. Yes or no? It cannot attain the value 10.
Yes, sir.
Now, can I say it can be greater than 0? Can I say? I'm
Sir,
actually doing something
can't
wrong.
we say that it's not less than 3?
Exactly. That is what I was trying to identify earlier. So, in this scenario, it can attain how many integers? 12 integers, if you check, right?
Yes, sir.
But the possible values has been diminished and it has came down to 6. Yes or no?
Yes, sir.
So earlier we had 12 choices. Now we have 6 choices. Okay. So here my favorable choices are 12, where my total choices were supposed to be, sorry, favorable choices are 6, where my total choices are supposed to be 12. So this is the probability, favorable by total, right?
Yes,
So
sir.
this will lead me
Yes,
to
sir.
half.
Sir,
Okay.
what is an auxiliary equation?
Um, Basically a equation with help of which you are solving another equation. I could have told that there are two equation 1 and 2, but as it is not an equation, it is an inequation. That's why I told this an auxiliary equation. Okay.
Okay, sir.
And you could ask why you are not telling this as auxiliary inequation and you can solve this one. I'm not telling because I'm going towards the direction of the values with help of this inequation only. This is my primary condition. I'm trying to satisfy this one first, then I am trying to satisfy this, right?
Yes, sir.
I'm trying to get all the possible ordered pair for x and y, and then I'm filtering it on the base of this equation, right? That's why I'm telling it auxiliary. Otherwise, you could have named this as equation 1 and equation 2. Okay, clear? Okay. So here also you can see that they have uh, marked half as the correct answer. Now I would like to ask you guys to try solve this question. Maybe this will our last question for today. I'll be sharing you the question papers for previous years. You can try solving, and whenever you face any issue, you can just ask in the group only. Just try solving it. Remember, they have mentioned that two products can be sold independently. Okay, so these two events, that selling product A and selling product B, are totally independent. So here's a conditional probability coming, but let me know when you are done. Can anyone tell me what is the motivation of solving? Like, which path you should be following while solving?
So maybe to find out at least one product which is sold, we have to
Mhm.
find out the probability of not selling any of the products.
Okay. Yeah, fair enough.
And we can subtract that from 1 and then we'll get the value.
Okay. Hmm. You got it. Like, suppose you got it, say, 0.8 or something like that, or 0.79. After that, what should you do? There's a condition given. There's a condition given
Yes, sir.
that product B has been sold already, right? So remember that as well. No, they have asked that the one product which has been sold is product B only, not product A.
Okay, sir. So then we can divide the probability of selling B divided by the probability of selling at least one product.
Exactly. So this is the scenario. Suppose you are you have been given with this probability of selling A and B. So uh, this is the probability of selling neither. Okay, you are just taking the complement of each and multiplying them. Okay, and then from that you can find out that at least one being sold if you are taking complement of that as well. Now you're just applying the conditional probability. Okay, and you will find this. Okay, what will be the answer? It will go around 6 8. Okay, 0.89. Okay, it will be close. Clear?
Yes, sir.
Okay. Any doubt so far what we discussed today? Anyone? If no, then we'll be like ending our session here. Um, any topic you faced, like, yeah, this topic should be covered a little bit more, or you are personally facing issue with, you can tell. Any feedback for today's session?
So the only thing is, I wish we could have solved a little more problems. That would have been great.
Hmm.
But since we
Also
have a
wish, but
constraint,
we had a time constraints because the house has another event from 10.
yes, sir. So that is the only feedback from my side.
Okay. Maybe for the ET, we'll be trying to conduct more than one session for revision purpose.
Sure, sir.
Mm. Okay. Uh, Apart from that, I'll be sharing the previous year questions and the notes in the group only. So you'll be able to access. If
Sir,
you're
which
not,
group are you referring to?
I'm talking about Chi-Square member group.
Okay.
So this event is hosted by Chi-Square, the statistics club, which is running under Nilgiri House. So I guess you are aware of. So you can find all the materials over there, though everything is there already, and still I'll be reposting it. Okay.
Sir, is there any invite link for that group? I don't think I'm in it. So
Okay. Mm, Let me check. Okay, hold a minute. I'll be sharing the link in the chat box only.
okay, sir.
Mm, mm, okay, the link is not available. Okay, I'm sharing a membership form in the description so that you can access it, and once you fill it, we'll be sharing the link. Okay.
Okay, sir.
Apart from that, I'm sharing the pyq questions link as well, and the notes in the chat. Okay, cool enough.
Yes, sir.
Yes, sir. Sir,
Yeah, go ahead.
how can receive more solved PYQs
How you can receive more solved pyqs? Okay.
in all
uh,
subjects foundation level?
see, I have shared three links. One is for Google form via which you can join Chi-Square. Once you are like filling it, we'll be sharing the link where you can do the statistic culture. You can come talk about statistics and different things. Second link is for a spreadsheet from where you can access all the pyqs available with our house, like for last 3 4 3 years. And
Okay, okay,
the
sir.
third link is for the notes regarding your statistics one paper. Okay,
Thanks, sir. Thank you so much.
you'll be able to access. But I guess you guys are available with the student ID, right? Yeah, of course. Once you were logging in with student ID, then only you can access. Okay,
Yes, sir.
thank you guys.
Thanks. Good night, sir.
Yep.
Sir, good night.
Thank you,
Mm,
sir. Good
yeah,
night, sir.
yeah. Good night.